Hello friends and welcome to my channel. If you follow my channel, then you know this lab bench power supply made by me. Few days ago this power supply got bad for second time and I decided to make a new approach. And I designed this lab bench power supply from a PC power supply and this module. If you will watch this video, you will learn why that lab bench power supply got bad and how you make DIY power supply like this for you. So, for the second time, this step-down module it's broken in power supply, and this step-down module it's good if you use it like it was designed with this original potentiometers and put in one position will work perfect. But if you replace these potentiometers with potentiometers like this and you move it a lot of times, if you will buy one of these and we will test with amps at 0 and voltage to 0, you will see on the voltage meter voltage and the current of 2 amps current and 2 volts. If you increase the voltage and the current, voltage and current will drop to 0. And this is the sign that the voltage divider of this module it's not perfectly designed. And that's why if you use this module to the minimum adjustment, will be a big chance that this driver will got bad, will defected. I checked these MOSFETs and the MOSFETs are good. Problem is here on this driver. So that power supply is made from a module like this, 36 volts and 5 amps, and a step down module like this, 30 volts and 20 amps. And because now it's the second time that this step down module got bad, I decided to make a new approach. And I built this module. I inspired from module, but I adjusted to my needs. And this small module will replace this step-down module. As you can see, here we have the voltage adjustment and the current adjustment. Here it's a PC power supply. You will receive all the schematics in the link in the description. So I got this power supply. I take off all the parts to the output zone of this power supply, and I keep only part from 12 volts and the part for 5 volts standby, and all of the other parts I took it down. and I use this module to command this optocoupler. And you can also, with a module like this, we can command any power supply, even this power supply, to make adjustment for voltage and for current. And for this you will have to take down all the parts from this regulation that commands this optocoupler and replace this part of regulation with a module like this. In my power supply I will replace this broken module with a module like this. Now, something very important. If you will use a power supply like this, it's better that you find a power supply with only two transformers. One main transformer and one for standby. There are some old power supplies that these have a third transformer for chopper. Has a IC here on the secondary part, and this IC in secondary parts with this third transformer will command the MOSFETs. But this configuration with only two transformers, it's much easy to modify for this. Now let's make some tests, and after test I will put this old module in this box, and I use this module, and I also will put a 5 volts USB for charger in the front of the box, because I already have 5 volts here. Now let's make some tests. It's all, let's check this. It's all good. Let's take it to the minimum. So I forgot to tell you that this module has a small disadvantage. When you will see the schematic, you will see that the starting voltage will be around 3 volts. This module cannot take down the voltage under 3 volts. You will see later why. But now it's not, it's modified, and the minimum voltage is 7 volts. But we can take it down to 3 volts. Now 7 volts. Now that's good. So this is the voltage, and the voltage is minimum. I can increase the voltage . That's the current regulation. So even 3 through this voltage potentiometer, I cannot low down the voltage under 7 volts. But from current regulation, I can low down the voltage, as you can see, even under 3 volts. Here we can increase the current, and now we can increase the voltage. Now we have 9 volts and 5 amps, 10 volts, 11 volts, 12 volts, 13 volts, that's not hot. So as you can see, now we have 13 volts from voltage, but if we can lower the amps, you can see the voltage is drop. So now let's discuss about this module. This is the basic schematic. I started from this. You will find also this schematic in the description. So schematic, it's very simple. This is the LED from the optocoupler. This LED, this is the command from the power supply. This is the output of this module. And now let's see how it works. I made some changes from this schematic. First of all, I supplied this IC from 5 volts this 5 volts standby. In original configuration, this IC was supplied from this wire, but I decided that it's more stable if we can supply from 5 volts, fixed 5 volts. I also see that if I let this original configuration, this stabilizer is supplied from plus. If we take down the voltage or the amps to 0 volts, if the voltage drop here to the stabilizer to 0 volts, even if we increase later the amps adjustment, voltage will not be able to increase again, and voltage will stay 0. And you have to shut down and start again to start this module. And that's why this stabilizer, I cut this wire, and this is also supplied from 5 volts here and 5 volts from standby. Now let's discuss how this works. First of all, the voltage regulation. We have here an IC 431, it's in configuration that 2.5 volts Zener diode. Here we have 2.5 volts, and this is the voltage reference. This voltage reference is put to the inverting input of this IC. Here we have a voltage divider, and this voltage divider goes to the non-inverting input of this IC. And this part is very simple. When the voltage here it's too high, then here the output of this IC goes to high, and this goes to, when this goes to high, then this optocoupler gives the command to the power supply and the voltage will decrease. And that's why it's the voltage stabilization. Now let's discuss about the current regulation. This part here we have a shunt resistor. I put 0.1 ohm, 10 watts, R2. These two resistors in parallel configuration. So here it's the same like the voltage regulation. On the input, on the inverting input, we have 2.5 volts from this Zener. And this voltage from this reference voltage goes here to a voltage divider. And in this non-inverting input, based on the position of this potentiometer, we have from 2 volts to 0.1 volts. And this on this non-inverting input we have this shunt resistor. So when the current is increasing in this shunt resistor, the voltage, drop voltage on this resistor will increase. And when this drop of voltage on this shunt resistor will be more than this this reference voltage here on inverting input, then this output will go high. And when output will go high, then this LED from optocoupler will give the command and this voltage will drop. When this voltage drop, also drop of voltage of this shunt resistor will be small, and this will stabilize, and that's why will be stabilized. And here we have two LEDs. One LED will, when this LED is on, that shows us that the voltage regulation is working. When the the other LED is on, that will show us that the current regulation is working. And these two diodes are here, a maximum, how to say it, maximum circuit with diodes. I don't know how to say it. And when we have a configuration like this, this will let the higher voltage. That's maximum logic with diodes. So when in this configuration on the output we'll have the voltage who is bigger than the other. If this voltage is bigger, we'll have here. If this voltage will bigger, this will go. Now it's working only on 18 volts, but I will change this voltage divider and I will take it to 30 volts. This power supply can give us 12 volts on 40 amps, but on 40 amps we'll need a big cooler. I decided to limit this to 10 amps because if I will use it to 40 amps we'll need a very loud cooler, and for me it's enough 10 amps. Now that we see how this works, let's put it all together in this box. Everything is put in his place, but it was more difficult than I imagined, because initially I made the test with this voltmeter, but this voltmeter works from 5 volts supply voltage. When I put this voltmeter ammeter, this work only over 7 volts. And I had to find a solution because with 5 volts from standby this not work properly. First of all, I tried to make double voltage, with 2 diodes and 2 capacitors, but instead of giving me 10 volts was giving me 25 volts and was too much for this display. And because I needed voltage over 7 volts, I had some choices. One of the choices was to use a step up and from this 5 volts make 7 volts, 8-9 volts. But I decided to use other solution. I modified this standby. I replaced the reference resistor and modified from 5 volts to 8 volts. And because I didn't have 5 volts, I had to use this step down module to make 5 volts for this USB. And after that I have to find the right combination for this cooler. So normally when I start this power supply, this cooler it's not starting, but when this heatsink it's warm, has a sensor, and only when this is warm, only then this cooler is starting. Now let's make some tests. We'll use this dummy load. I put these LEDs here. Blue LED it's current limiting, and the red LED it's voltage limiting. If I increase the current protection, now we can see the minimum voltage is 4.9 volts. That's the voltage with potentiometer minimum. I can low down to 2 volts, but I don't need under 5 volts, and when I really need, I will make another power supply with only 1 amp, and with this power supply I don't need under 5 volts. So that's minimum voltage, it's 5 volts, and now minimum current it's 0.3 amps. I calibrated this voltage and amps. Now let's make some tests. I will increase .12 volts. I want to show you something. Now we have 12.8 volts. Oops. If I take down the dummy load, it's 12.7. When I put, it's 12.7. That configuration is very stable. Now we have 1.5 amps and 20 watts. Let's increase to 2 amps. Now you can see the current limiting it's on. We have to, now we have 2 amps, 36 watts on this. It's very warm, even it's 100 watts, but I have to put it on a bigger heatsink. This main heatsink it's cold, and I think that will start, the cooler will start only if we use over 5 amps. It's not warm at all. This it's very warm. I think it's 60 degrees. It smells, this resistor. It smells because it's too hot. I have to... You can see, even if we have on voltage 20 volts, when we decrease the current limiting it's on, and decrease the voltage. Let's take it to 1 amp. It's not warm, it's okay. Now I put the case together and let's make the final test. Here we have 30 volts and I take the current to the maximum, 10 amps. And let's check the short circuit protection. You can see 10 amps, 0 volts. And if we you can see the current. Please be inspired to make yourself a lab bench power supply like this. After this schematic, you will find this in the description of the video. And I recommend this schematic because it's very simple, it's very cheap, it's very reliable, and as you can see, it's perfectly working. I told you that I am not happy with this module. It's not reliable, it's expensive and it's not reliable. So please make yourself a power supply like this, and if you did, please put your results in the comments. And if you find this helpful, please like and subscribe. Recycle and be creative. See you in my next video. Bye.